Hi, in this video I'm gonna create a mod for Tactical Breach Wizard, which is a Unity game, dx11. We already have a mod for Tactical Breach Wizard actually, but I think it's gonna be a good tutorial, or at least good knowledge. This is not an actual tutorial. I'm not gonna explain how to install RenoDX or how to set it up. You can check the contributing README file for this. I'm just gonna go over what I usually do when creating a mod. I'm gonna show different tools and explain my logic throughout and my thoughts. So first thing we want to do before doing anything else when creating mods is take a reference photo. This is gonna be an SDR shot that we're gonna compare our mod to, in case we mess up something like mid-gray or the contrast or the colors. What I usually do is I run the PC in SDR and take a screenshot. You can also use Lilium's map SDR to HDR and take a photo that way. Basically, just run the game, take a screenshot, make sure the screenshot is actually representative of SDR. After that, we're gonna create a new branch for it. First thing we want to do is when CMake configure, whenever we add shaders or anything, we should run this command. I usually run it before doing anything. It's a good habit to keep. We're gonna build the diff kit after running configure. Just make sure, I usually code with release with debug info. Release doesn't affect performance. You can just use it as a release preset. The only thing that you have to keep in mind is that the diff kit has to match whatever preset the mod is set as. So I'm gonna build the diff kit in release with debug info. And while it's building, shouldn't take a while, we're gonna use the generic folder as a basis for our mod. A generic copy, call it tactical bed. We're gonna keep it at these values. I don't wanna adjust it as much, even though I usually don't include all of these options, gamma correction and such. We don't really need that. And the add-on, already takes into consideration whether the game is dx11 or dx12. It handles both of them. There's just this thing, which is force borderless is fine. Swap chain encoding, I think it's set to HDR10 by default. Yeah, if it's set to 4, we're gonna change it to sRGB. HDR10 is a little bit more complicated, not with the swap chain proxy we're using nowadays, but I don't wanna deal with PQ. I think sRGB is better. Some games might require HDR10 though. If the game is using frame generation or such, it might throw bugs with the sRGB. Anyway, we're gonna keep this sRGB for now. We can upgrade through the options here, but we're gonna do it manually later on. For now, let's keep it as it is. If you include this at the end of the mod swap chain use, the mod is gonna upgrade the swap chain. If you remove this, it's not gonna upgrade the swap chain, but also all of the resource upgrades and such won't run. So because we created a new folder, let's rerun configure. And build it. The reason we're building a mod, even though it's empty, which doesn't have anything, is first of all we want to upgrade the swap chain. Also, we're gonna use the sliders when developing with the dev kit instead of hard coding values. Go rel with debug info. You have diff kit and technical build. Before we run this, actually after, I'm gonna use reshed as well. As you can see, it's stuck at 203. This is because this is the value that UI brightness is set at. The mod isn't actually working. UI brightness is just set up to limit at the final step. Game brightness isn't working and all the other sliders won't work. If we go to advanced here, we can use these to resource upgrade, but I usually don't, we don't really use this. We don't expose this to the user at all. And most of these settings we're not gonna use. I think short views included all of this in case people want to experiment with stuff. And it is easier to use for beginners, I believe. Anyway, so we made sure that the plugin is actually working and it's upgrading to sRGB. Now what we're gonna do is we're gonna take a render doc capture. Before that, let me show you how the diff kit shows it. We go to diff kit and snapshot. Diff kit is showing the formats, each shader, pixel shader. We're mostly gonna work on pixel shaders or compute shaders. We see vertex shaders as well, but we never needed them. I don't think any mod uses it. Anyway, it's showing in dx11, the diff kit is pretty good. It's showing you content buffers, the values. It's showing you each shader and what RTV, render target view, which means the output of the pixel shader, and you have SRV. Yeah, you have multiple SRVs, which is source resource view, I believe, which is basically the input. As you can see here, it's also, for some of them, I think it shows you the SRV itself. I don't know why it's not working with the LUTs. Anyway, and here we have the list of the shaders. Before we start using the diff kit, I would recommend taking a render doc capture. It's gonna give us a better idea on what's going on. Also, it's best practice for dx12. The diff kit is not gonna show us all the details we want in dx12. So oh, we want it without the mod. So let's disable reshed. Reshed might hinder it from injecting. Steam sometimes also throws up a fuss. So we got a capture here. It's showing us the graphical pipeline, how everything is going, all the inputs, outputs of the pixel shaders, and it's giving us a history. So now let's run the game with the mod, and we're gonna start looking at the shaders themselves. First thing we want to do is find the output shader, which is usually what's using the LUT. So if you go here and look around, you can do it in DivKit as well for dx11. You can see that it's rendering the UI, which is usually the step after it finishes color grading and outputs. Took me 10 minutes to find this shit. Anyway, here's the LUT, the shader that's using it. I think this game is a little bit weird that its LUT doesn't actually clamp. So even after the output, the colors are above 1, which means that there are HDR colors. However, we're gonna saturate it just to replicate the behavior. Later on, one of the textures. So right now this texture is RGBA 16, but later on it's gonna be converted to RGBA 8, which is gonna be read as UNorm. Anything UNorm means that the range is 0 to 1. Even if it's RGBA 16 UNorm, the range is gonna be 0 and 1. For sRGB, you're gonna have to unlock that by upgrading to RGBA 16 float. But for PQ, you're gonna have to PQ encode it, which is a complicated process because you're gonna have to carry that PQ along the chain. So the game is clamping at the very end, but it's not clamping through the code, it's clamping by using a different texture. What we're going to do is just use saturate and treat that as SDR. Now for the LUT is 32 by 3. I don't know why it's showing 33 here. And we can see that it's not from disk, it's not a saved file. We're getting it from a compute shader. The compute shader gets, this is how Unity does it and most engines, honestly. The compute shader gets one LUT or multiple LUTs and it outputs the 3D LUT. Now, you can imagine the compute shader here as a function. So it takes in the pixel color value and it outputs a LUT, right? But the LUT is kind of like a function which is tone mapping the image and adjusting the colors or whatever. It takes in a certain color, it outputs a certain color. At the same time, LUTs can convert to different encoders, and sometimes they require different encodings as input. So some LUTs require PQ input and output sRGB or something like that. But the input is usually 0 to 1. So the input is not going to be linear. We're gonna see that once we look at the shader code. It might make more sense then. Anyway, we found this here, and we're gonna go to resource by right clicking. You can see where this texture is being used. This is the untone mapped image. How do we know it's untone mapped? Again, because if we go here, the pixel values are above 1. Make sure you look at somewhere bright. Yeah, so back to the game. Yeah, go back here. As we've seen later on in the chain, it's RGBA 8 typeless. We're gonna have to upgrade this. We can do it through the add-on by clicking on the options, but we're going to do it the old-fashioned way by adding it to the add-on itself. I'm just gonna copy it from the actual folder. Usually for Unity games, you have to upgrade all the textures. That's why we use ignore size. But for other engines, the internal textures are usually RGBA 10 or something. They are usually higher bitrate up until the very end. I don't think we need this. Let's try without it. So we have typeless. Let's add unorm as well. Actually, keep it typeless. Why not? We're gonna build multiple. Throughout the development, we're gonna make multiple builds. So we might as well create a symlink. Oh, I forgot to build. According to the capture, once we upgrade the textures, we're gonna get an HDR image. Because the LUT itself doesn't clamp. Yeah, and this is what we're getting. This is without a tone mapper. So we are getting the untone mapped image, but the sliders are not working. The reason it's limited to 1K is because we have peak brightness as 1K here. If we unlimit it, it's gonna increase. Let's keep it at 1K. And this is 203. As you can see, even this is controlling the whole brightness. So we're not actually, we have to inject the tone mapper. Another way of finding the shader, if we can't rely on this, is from the bottom. First of all, because we don't need vertex shaders, so let's hide them. But we start from the bottom and disable the shaders and see what each does. We should get some UI elements because the game tone maps and then outputs the UI or draws the UI. We're looking for something that will either do something like this, so hide the whole thing, or will give us untone mapped image or maybe a black render. So here's the shader, the output shader. Cause see, we're getting the unlotted image. So we dump this, and it should match. Hmm. Let's try decompiling it and see what we get. I think I might zip this and include it somewhere in the description. Everything is already configured. Decompile. We use different decompilers for shader models. 3D Migoto for anything below 6, and Short Fuses decompiler for any for 6 and above. 6.6 and 6.2 or whatever. You can use this CMD. It's gonna use the test folder. You can adjust the folder if you want. Just run it. It will check the shader model version and use the correct compiler. So we're gonna add this here. It's good practice to name the shaders whenever we add anything. But we got the wrong shader. As you can see, this only has two inputs, texture 1 and texture 0. So this is the wrong shader. I believe it's this one, because this is the compute shader that's outputting the LUT, and this is the actual picture shader that's using the LUT. Also, we have some sRGB values. You can double check it here. Keep in mind, if it's showing green, this means this is the swap chain. You can see this is our pixel shader, and it has 4 sRVs, so 4 inputs, which matches what RenoDX shows us. So dump this, and might as well dump the LUT builder. We're not gonna use it, we don't need that anymore, but maybe it's gonna contain some interesting info. Yeah, it failed to decompile the compute shader, which is something you're gonna face with compute shaders. They usually fail. We're gonna call this output because it samples the lot. You can call it whatever you want, really. It's just for the developers. But we usually call whatever samples the lot output. As for this shader, we're gonna try and see if someone else has included it in a different project. You can see that Awaken Astral Blade uses it as well. So we're gonna copy it. Thanks to Whoosh for adding this. We're not actually gonna use it. I think I might delete the file. I just want to show you how it looks. So inside the LUT builder, as we said, it's a function, it takes in a color, it outputs a different color. Let's have certain optimizations alongside them. So we have, I believe, SEES values. Oh, actually no, it's not using SEES. Whatever. So yeah, it might be SES. Or Whoosh made a mistake here. You can read the code and understand it, but for the most recent method, we're gonna use the tone map pass, so we don't actually need the LUT builder. We're only gonna use the output. Now to load this, we're gonna give it the path of our live development path. And you can see that it loaded the file. You can also go to the original if you wanna compare. First thing we're gonna do is we're gonna saturate this, because RGB is gonna saturate later on. And this should match your reference photo. Now, the second thing that we want to make sure of, I wonder if this is UI, doesn't matter. The second thing that we want to make sure of is we want to understand what color space it's using, BT2020, BT709, and what encoding it's using, if it's using any. Because RenoDX tone map pass is gonna require BT709 linear, so not encoded to anything. If we go to the top, we can see, again by consulting the render doc capture, T0 is the actual texture. So if we go float on tone map, this is the untone mapped image. Now that we got the untone mapped image, now we're gonna have to check the actual logic within the shader code, trying just to figure out what it's doing. Though, to be fair, we just need the untone mapped image and the SDR image at the end. The only thing we have to keep in mind is which color space the code is in right now and what kind of encoding it is in. So we have sRGB, PQ, whatever for encoding, and we have color spaces like BT709, BT2020, and such. Right now, this is sRGB encoded. Well, at least we have some sRGB stuff here. So we know that it's been BT709. PQ uses BT2020. Just keep that in mind. Anyway, so bit by bit. First of all, we have this number 2.4 and we have 0.404. This is decoding sRGB and it's applying it to our untone mapped. So our untone mapped here is actually in sRGB. You don't have to actually memorize the numbers, just you can globally search it, not in games, but in shaders. As you can see here, we are inside sRGB namespace, and decode we have this number, which is close enough. It's not gonna be an exact match. we don't have 12.92, but we have 2.4, which is this one. So Anton mapped, let's decode it. Oh yeah, if we want to use RenoDX functions, we're gonna have to include shared.h. Don't forget to do that. We're gonna do RGB decode save. Let's see what that gets us. The darkened image. Actually, I find I spent a little while because I didn't know why we're getting a darkened image, but this is because of what the generic code does, or the generic code we copied. Basically, we are gonna have to run intermediate encoding. So here we have intermediate encoding. I think the default value is gamma 2.2. At the very end, just run RenoDX draw render intermediate pass, and this is gonna switch it to the right format. I'm gonna explain the intermediate tone map and final pass swap chain pass later on, and we're getting the correct colors. Now this is untone mapped with correct colors. We're still gonna need the SDR image, which is here, and we're gonna need to run the tone map pass. First of all, let's go bit by bit. So we realize that this is sRGB encoded, the untone mapped image. In the middle, it's doing some stuff. This is actually ARI encoding before LUT sampling. T2 is the LUT. If you go back to the render doc capture, you can see that texture 2 is the color grading LUT. So this is the LUT output. If we go further, now we don't know what the LUT output encoding is or what color space it is in, because it can output any color space and it can output whatever encoding. If we have the LUT builder, we can follow the logic there, but let's assume that you don't actually have the LUT builder, or you don't want to bother with the LUT builder. You can test multiple stuff. So I have here SDR, and let's go render intermediate pass SDR. This is a little bit bright, or at least brighter than normal. Actually, sorry, this is linear, yeah, which are the correct colors. If it was sRGB, let's encode it. It would look like this. If it's washed out, it's most likely in sRGB encoded. If it's darkened, it's either gamma encoded or sRGB decoded. So you're in the wrong, you decoded wrong. So this is linear, and later on they encoded to sRGB, and I think some of the code also adds noise or whatever. So at the very end, right now, O0 is SDR sRGB encoded. So let's change it, or let's decode it. Decode. Yeah, switch it. Don't forget to change the variables. Now we're getting the correct SDR image. We still haven't run tone map pass. Give it untone mapped, and now untone mapped and SDR, both of them are linear BT709, because we followed the code and this is what we figured out. And this is the final image widget. which is incorrect. We're not getting the LUT colors. I think this means that tone map pass is not running correctly. Yeah, we're not getting the LUT colors. 0, 1 tone map. Now, one reason for this, for tone map pass and anything within the draw namespace, tone map pass, intermediate pass, they get their variables from here. The values, sorry, they get them from here. So you inject and RenoDX knows what the value is. I think sometimes this can throw bugs. We're gonna have to rebuild the shader if we wanna add this. Actually, let's do it. You're gonna have to inject it first to get the right, for tone map pass and such, to get the right values. So here we have custom shader entry. Let's add our shader. And we're gonna rebuild. We added a new shader, so let's run configure. Build. We already have a symlink, so we don't have to copy. By default, this is running our code because we're adding it through the mod itself. We don't have to add it through divkit. Oh. That's a bit weird. I wonder if divkit doesn't recognize these. Let's try using the hard-coded values instead of the sliders. Keep in mind the mod itself is working, but there is an issue with the divkit and the mod. Yeah, with the hard-coded values it is actually working. I'm not really sure what's causing the issues with the divkit. So it wasn't an issue with the divkit actually, it was an issue with the defaults in the generic folder. We have color grade strength here, and the default value should be 1.f, but because it's not defined in the add-on, it defaults to 0. So if we hardcode this to 1.f, you can see that it will get fixed, and the whole mod is working as expected. I believe short fuse is gonna fix it, no worries. So the last thing I think any new person should know is what's going on with tone map pass. So just to recap what we did so far, we figured out untone map, and we figured out that it's sRGB encoded, so we decoded it because we want untone mapped and SDR to be in linear BT709. So we just got untone map, we got the SDR value here. Okay, just to not confuse you guys. SDR, then SDR, sRGB, decode. Might as well add safe. And we got the SDR. We made it linear as well. We just called tone map pass. It's gonna handle everything for us. And at the end, we called render intermediate pass. And everything should be working perfectly. Not that. Gamma correction. You get all of these. None for the, and we get vanilla. I think vanilla is not working properly for some reason. Doesn't matter. I'm not gonna debug it now. The last thing that I think people should know is what tone map pass and intermediate pass are doing. we actually have a third step, which is swap chain pass. I'm not sure how. It's gonna be a little bit hard to explain. So we have a proxy shader, proxy texture at the end. We have it defined here. This is the code for the proxy pixel shader and vertex. And we have we define it here. Proxy. Yeah, we define it here for dx12, dx11. It's already set up. Now the proxy shader, or the proxy texture, what it does is it's a final step. So you can imagine it's something after the swap chain here. Present, back buffer, then our proxy shader renders. The proxy shader is RGBA16 by default. And we're gonna run our swap chain stuff on it. So we have 3 steps. Tone map. Okay, this is gonna look ugly as hell. Tone map, which we give it untone mapped. First step, tone. Okay, screw this. No. I'm just gonna write it here. So we have tone map pass. And then we have intermediate pass. And at the end we have swap chain pass. Each one handles different things. Tone map pass gets untone mapped and SDR, and it just renders the tone mapped, the final image, the tone mapped image. Its output is always in linear BT709. I say always, but maybe we can configure it from shared.h. Now, render intermediate pass. If you don't know what gamma mismatch is, then you should learn it, but basically it handles the gamma mismatch, and it's gonna adjust our output, the render itself, in accordance to our settings. So what does that mean? First of all, we want to scale it up, the brightness of our output, and then we're gonna divide it by our UI luminance value. So if we adjust game brightness, I believe the scaling is gonna be game brightness, UI brightness, and at the very end we do the other way around, so UI by game brightness. Yeah, scaling is gonna be the same once we divide, one we multiply and one we divide. So what this thing render intermediate pass is gonna increase the scaling, and also it's gonna do the gamma mismatch thing for the output, and at the end it's gonna gamma encode it. So our UI is sRGB or gamma or whatever. The output is gonna be gamma encoded. The UI is gonna be drawn on the proxy texture, which is already gamma encoded. UI is gamma encoded. So now we have both output and the UI gamma encoded. So what swap chain does is it decodes the gamma. So now we have both output and UI decoded, and it reverts the scaling as well. The scaling is done so the UI and game brightness sliders work. Instead of searching for each UI shader, we just do this and it's gonna handle it automatically. As you can see, the UI brightness already works, even though we haven't found any UI shaders. Gamma correction and such, I believe most of these are for the tone map pass. Color grading as well. Some of these intermediate encoding, this is for the render intermediate pass. Swap chain decoding is for the swap chain pass. I don't think whoever is working is gonna have to worry about most of this, but it gives us some pretty cool tools. So for example, if we want to output in HDR10, swap chain pass already handles it. We just have to tell it to render in HDR10 here instead of sRGB. If you want to understand what it's doing manually, then we should go, yeah, we can define these instead of these here. Let's comment it out. So the encoding, because HDR10 is BT 2020, so we're gonna tell it, sorry, swap chain encoding instead of sRGB. 4.f is HDR10 value. And here, instead of BT709, because HDR10 uses BT 2020, we're gonna change it to BT 2020. Preferably when you change anything for the swap chain pass, you should rebuild the mod. So let's do that. We have an error, unexpected integer. Oh, I forgot to delete this. So now if we run the game, I believe I made a mistake somewhere. I think it's using, oh yeah, it's using this because in the add-on for HDR10 we have to set this to true. Let's copy this instead of using the slider. Let's just manually assign it. So set use HDR10 to true. If you notice, the game was washed out. This means that we have some encoding mismatch. Oh, okay, let's use the sliders instead. I don't see a reason why the game would reject HDR10. Oh, it does reject HDR10. No, doesn't matter. So, yeah, I think this goes over most of what you need. Again, this is not a tutorial video. This is just to give you a starting point for how to do mods. There is a lot more information. You can check other mods and learn from their code. You can check the shader code. I believe this is the best learning resource. If you want to see how color converts are working, BT709 to BT2020 or whatever color converts, you can check the and search globally for the variables if you see any weird numbers, and maybe you're gonna find it in other mods or something like that. I hope this is helpful to someone, even though I know it's super scuffed, but yeah, that's all.